Okay, guys, so today we're going to be talking about surface area. It's lesson 12. First, I'm going to go over a review about what I feel a lot of us are struggling on. So you're just listening and watching right now. I'm hoping seeing this helps some of you. So I'm going to focus here on the left when it says, what is area? So we're going to focus on something easy like a rectangle, right? So remember, if we're finding the area, we're going to multiply the 5 and the 3 together, and that's going to give us the area of the rectangle. Okay, so that's something very easy. Now, something I feel that a lot of us are not understanding is this missing length. So what I wanted to do is I wanted to give you an easy example where you can kind of see where all this is happening. So it says if the area is 15, what is the length? So this 15, they're telling you the area. So notice on this side, we're finding the area. So we would do base times height, right? But on the right, they already gave us the area. This whole area of this is 15. They already gave us that answer. So now we're looking for, well, what is that missing length? And most of you know that to find that, you would divide the 15 by the length that they gave you, which is 5. So 15 divided by 5 is 3. So that missing length on that side would be 3. So that's kind of where this whole missing length situation comes from. Okay, so now I'm going to show you another example, right? So on the left, it's asking what is the area? Remember that we should be dealing with 90-degree angles. So that 3 is there to trick you. So the numbers that you care about are 6 and 4. That's the base and the height. So the base times height is 24. 6 times 4. Now, if you look on the right, it's the same thing that we did in the triangle. Remember that the 3 is not a 90-degree angle the way that this is to the base, right? So that is 90 degrees right there. So now it says, well, if the whole total inside here is 24, if the total is 24, what is the question mark? What is that missing length? And most of you know what you would do is divide. You would take the 24 and you would divide it by 6 and you would get 4. So that missing side is 4. 6 times 4 is 24. Okay? Now, here's where I feel a lot of us are lost and we were frustrated on the quiz. So I want to take a minute on this. So it says, what is the area? So I told you that the rectangular formula is base times height divided by 2. That's what I taught you. Okay, well, your base is 5, your height is 4. So 5 times 4 is 20. And I feel like we all understand that. Now, remember that a triangle is half of a rectangle or a square or a parallelogram, however you want to look at that. So we need to take half of that area. So we would do 20 divided by 2, and we would get 10. So the area of this triangle is 10. Now, here is where we're lost. Here's the problem, and we're going to get a lot of practice with this today during the practice that we do as a class. So it says, if the area is 10, what is this missing side? Well, remember on the left, I know that at the end, we would divide by 2. So in my brain, I automatically think, well, 10 needs to multiply by 2. We need to blow this up, right? Because what happens is at the end, we divide by 2, right? So I'm going to make it bigger first. Okay, so pretty much where I'm at is right here. It says something times 5 divided by 2 makes 10. Okay, well, I know that 20 divided by 2 makes 10. Okay, so now what I need to think is what times what makes that 20 that I wrote above. And you already have a length of 5, so that's where that comes in. So something times 5 makes 20, and that's 4, right? So 4 times 5 makes 20. And then I divide it by 2 to get the 10, which is the area that they originally gave me. And I can check my work. Okay, so let me put a different color in real quick. And I can check this out. I can do 4 times 5 is 20. And then I need to follow my formula. Well, 20 divided by 2 makes 10. And that's what they told me right there. So that's the missing length. The answer is 4. All right, so now we move on to today's stuff. It says, let's cover the surface of some 3D objects. So the surface area of a figure in square units is the number of unit squares it takes to cover the entire surface without gaps or overlaps. If a 3D figure has flat sides, the sides are called faces. Okay, so the flat parts of a box we call faces. So the surface area is the total of the areas of the faces. So it says, for example, a rectangular prism has 6 faces. The surface area of the prism is the total of the areas of the 6 faces. Okay, so here's something that you can kind of see with your own eyes. So it says, so the surface area of a rectangular prism that has an edge length of 2, 3, and 4 has the surface area of this. So basically you're multiplying the 2 and the 3, that's this, but there are 2 sides. Okay, and then you're multiplying the 2 and the 4. And then there are 2 sides to that. And then you're multiplying this 3 and this 4. And there are 2 sides to that. And we would add all of those, 6 plus 6 plus 8 plus 8 plus 12 plus 12. And you would get 52. And you will get practice with this today. Okay, so real quick, some vocab. The face. Each face or each flat side of a polyhedron is called a face. For example, a cube has 6 faces, and they are all squares. This is an example of a cube. Then I put in a triangular prism for you guys. So this here, where I'm coloring, that would be a face. This would be a face. There's another side that you don't see over here, and that's a face. And then there's another side over here that you can't see because it's 3D. Okay, so now we deal with this concept of surface area. The surface area of a polyhedron is the number of square units that covers all the faces of the polyhedron without any gaps or overlaps. So for example, if the faces of a cube each have an area of 9, then the surface area of the cube is 6 times 9, which is 54. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and there are 6 faces. So we just do 9 times 6. Okay, so I'm going to show you a video from the curriculum. Okay, so you kind of get the idea here. He's putting sticky notes along the entire outside of this cabinet. Okay, so we're going to need to know about that when we're dealing with this. So you're in your book, you're on page 77, we're toward the middle, and we're going to start here. So these are just some things from the video for you. So it says, we're on page 77. How could you find the actual number of sticky notes it will take to cover the cabinet, excluding the bottom? What information would you need to know? So you're going to write what I have for number 1. You're going to write, we would need to find the area of each side of the cabinet, excluding the bottom, and then we would add them together. And the information that you need to know is the measurement of the cabinet edge lengths in sticky notes. So if you need to pause the video, go ahead, but you need to write all of that for number 1. All right, so now I'm going to move to number 2 on page 77. So use the information you have to find the number of sticky notes needed to cover the cabinet. Okay, so what you would do, you're going to write this for number 2, multiply the number of sticky notes along each side, and add all the products. So if you need to pause the video, go ahead. Okay, so this is what eventually happened. He went and finished this. So let me try to play this. Okay, so that's what we would do to find the surface area of the cabinet. So now you're just kind of watching and listening. We're going to go over this in the practice in just a minute. So we will find the surface area of this cube. Remember that there are 3 sides that you cannot see, guys. So this is 2D, what you can see. But the cube, that's a Rubik's Cube. It's actually 3D. There's a side over here that you can't see. There's a side over here that you can't see. And then there's this bottom that you actually cannot see. So what we would do, like as a strategy, is we would multiply the top. It's 2 by 2. And then I have the sides we can see is 2 by 2 by 2 by 2, right? That's the blue and the red and the yellow. Now you got to factor in the sides that you cannot see. So the bottom is 2 by 2. And then the sides that we can't see is 2 by 2 and 2 by 2. So it says there are 6 combinations because the cube has 6 faces. So here's what I did for the work. 2 by 2, 2 by 2, 2 by 2, and keep going, and you would get 24. Or what most of you would do, you would just say, well, 2 times 2 is 4, and there's 6 sides, so 4 times 6 is 24, and you would get your answer. So the last one, and this one is a little bit different. We will find the surface area of this cube. Remember that there are sides we cannot see. There's a bottom you can't see, this you can't see, and that side you cannot see. Okay, so what we're going to do is we're going to multiply all the combinations. So the top is 2 by 2. The green, it's a side we can see, is 2 by 3, but there's 2 of those, right? That's this one over here. And then the side we can see, the red, there's 2 by 3, but remember that there's a whole side over here that I said that we cannot see. And then the bottom is 2 by 2. The bottom is always the same as the top. And we're going to add all these combinations up. So 2 by 2, 2 by 3, 2 by 3, 2 by 2, 2 by 3, 2 by 3. And then we would add them together. 4 plus 6 plus 6 plus 4 plus 6 plus 6 would be 32. So go back to the meet, start your practice, and we're going to do this as a class. Thanks, guys.